Today we are going to be looking at gas laws. As you know, gas law we have like four laws under gas. Namely, we have Boyle's law, we have Charles' law, we have Gay-Lussac's law, we have general gas law in physics. Now, Boyle's law. Today we are going to treat Boyle's law. I am going to be taking you um, the what did the law, and at the same time take you on do some exercise like application of Boyle's law. So in our next video, we are going to do the experiments. I'm going to be showing you video of experiment on to verify Boyle's law. Now let's start. What is what Boyle's law states that at a constant temperature, the volume of a gas is inversely proportional to its pressure, which means that when they say something is inversely proportional, it simply means the higher the first, the lower the second. The higher the first, the lower the second. Just like the more we grow, the weak we become, our bone become. So just like that. So that's inversely proportional. So the higher the volume, the lower the pressure. The higher the pressure, the lower the volume. But something must be kept constant, and that is temperature. Temperature must be kept constant. So, and this can be mathematically stated as P1 V1 equals to P2 V2. It shows that pressure 1 volume 1 is equals to pressure 2 volume 2. Or we can say that pressure 1 volume 1 equals to K, equals to constant, and our constant there is temperature. But in the case whereby we are giving pressure 1, we are giving volume, then we are not giving volume again, volume second, and another volume. We have to find the second pressure. We can use this formula. So let's look at a question, an application question under Boyle's law. The first question here is state that at a pressure of 3 atm, a given mass of gas occupies 300 centimeter cube. What volume will it occupy at a pressure of 1 atm, given that the temperature remains constant? In this case now, whenever you are given problems to solve in physics, the first thing you have to do is write out your parameters. The first parameter I have here is the pressure. So at a pressure of 3 atm, that's pressure 1. The first pressure is 3 atm. A given mass of gas occupies 300 centimeter cube. That's volume 1. So we are going to write that one to V1. P1 is 383. V1 is 300 centimeter cube. Then what volume will it occupy at a pressure of 1 atm? So here we are looking for the second volume, that's V2, giving the P2 as 1 atm. Let's follow me and work with me and see how we solve the first question. Now we have P1 equals 3 atm, we have V1 equals 300 centimeter cube, then we have P2 as 1 atm, then V2 is unknown. Okay, from Boyle's law, which states that P1 V1 equals to P2 V2. So by having this, we can just divide both sides by V2, since we are looking for V2. So we can make our V2 the subject of formula by dividing through by pressure 2. Okay, so P1, what's our P1? Our P1 is 3 multiplied by V1. Our V1 is 300, and then our P2 is 1. So 3 times 300, that is 900 centimeter cube divided by 1. So our answer is just 900 centimeter cube. So easy like that. So let's look at another question. At times, question might not be as easy as this. At times, they can give us we can be given capillary tube. Like this one now, we have the question given said the setup below shows a capillary tube of uniform cross-sectional area in two different arrangements. So using the data in the diagram, calculate the pressure of the atmosphere. Okay, in the first case where we have, in this where my cursor is, first case, the capillary tube is upright. It's upright. Then we have the mercury in between, and then that mercury has trapped some air inside the capillary tube. We assume that the air is dry. Okay. Now the length of the mercury is 15 cm. So the length of the air inside the tube is 30 cm when the capillary tube is upright. Okay. Now when the capillary tube is inverted, the dry air extended to 45 cm, and then the thread remain constant. Then the atmospheric pressure is not shown there. So in the first case, whereby it is upright, the atmospheric pressure is directly on top of the mercury. So the total pressure on the air is going to be the atmospheric pressure plus the pressure from the mercury. So both atmospheric pressure plus the pressure on the mercury all added together to form the total pressure that will be acting on the dry air when the thing is inverted. Then when the capillary tube is upright, I beg your pardon, but when the capillary tube is inverted, the total the pressure on it is less. The pressure on it is less, and that's why you can see that the length of the air is increased to 45 centimeter. So the pressure there, the atmospheric pressure, or the pressure when the capillary tube is inverted, is going to be atmospheric pressure minus the length of the mercury. That's minus 15 cm. That's what we are going to give. So it means our P1 here, our P1 in this case, your P1 is atmospheric pressure plus length of mercury, which is going to be 15. That is going to be, if atmospheric pressure is represented by H, we are going to be having H plus 15. Okay, let's look at the diagram. So I give the diagram as this. I use H to represent the atmospheric pressure. Then that means total pressure on the air here is H plus 15, and here I'll be having H minus 15. Okay, so let's look at the solution of it. How do we now solve it? I said let the atmospheric pressure be H. Now our P1 equal to H plus 15. That is atmospheric pressure plus 15, the length of the mercury, centimeter of mercury. Then V1 is 30 centimeter cube. Then when the capillary tube is inverted, it is H minus 15. We are not adding again, we are subtracting because the mercury is not exerting pressure on the air again. So we are going to remove the pressure from the mercury away from the atmospheric pressure. So we are having P2 as H minus 15, then V2 volume 2 as 45 cm cube as was given in the question. So according to Boyle's law, we have P1 V1 equal to P2 V2. We can say that our P1 is H plus 15 outside 30 equals to H minus 15 outside multiplied by 45. So let's open our bracket. 30 times 15, that will give us 450. Then 30 times H, that will give us 30H. Then 45 times H, that's 45H. 45 times negative 15, that will give us negative 675. Then the next thing is to collect the like terms. What are the like terms? Those ones that have H, take them to one side. Those ones that do not have H, take them to the other side. So it's going to be 45 minus 30H. 45H minus 30H equals to 450 plus 675. So 450 plus 675 will give us 1,125, and then 45 minus 30, that will give us 15 each. By dividing through by 15, our answer is 75 centimeter of mercury. So that is solution to that. Definitely, the atmospheric pressure on that day was 75 centimeter of mercury. So our next class, we are going to be talking about um, the Charles law, and very soon I am going to be sending. I'm going to create a video on the experiment to verify um, Boyle's law. Thank you.